Hey guys, welcome to information extraction from web pages part 5. So far we have discussed about what is information extraction and how well we can formulate it and how we can annotate a HTML tag and how to create a training set, etc, right? So in this video we are going to discuss about how well we can analyze and analyze the training data which we created and as well as the cleaning part of it, right? So if you remember in the previous videos we have saved it into a CSV format. The format looks something like this. Basically, we have extracted tags and correspondingly we have given label, right? Whether the given tag contains published date or not, right? The column name is date. So the main problem is the very imbalanced nature, right? I think 1893 is the number of HTML tags which doesn't contain published date. Only 6 tags contains published date, right? So this is very imbalanced. Let's see how we can deal with it. Of course there are like various approaches to deal with this, but I'm just trying to go through very intuition level, like how well we can clean the data set. All right. So for this session I think I'll be using Seaborn as well as Matplotlib, just for the fear of the very visualization. Okay, I'm not going to go so much of fancy visualization. Just for our understanding, I think I'm going to use histogram and PDFs just to make sure that we understand what kind of data it is. All right. So what I'm doing is I'm just reading the CSV file using pandas. As you may see here, it's 1895, almost 1900, right? So those many data points we are having. So let's these are the various columns we are having, right? So let's see, let's do some analysis on published date, right? If you see published date, I mean if you see the tags which contains the published date, these are the tags which you can see. That is a paragraph tag, div tag, span tag, and time tag, right? So these are the 4 tags contains in 4 different websites. I'm just telling you that we did annotate only 4 web URLs, okay? And this is what we got it. And this is the basic filtering which I'm doing here. So basically I'm removing the tags which doesn't contain p tag or div tag or span tag or time tag, sorry. So basically if a tag is not belong to any one of these tags, I'm just trying to get rid of this, because even if try to annotate more tag, I think let's say 40 websites or 50 websites, or let's say 50, in our case it's a blog, right? So what you will see is you will have very limited amount of tags. So I think this is one of the major filtration I'm doing here. So that doesn't mean that date cannot appear in any other tag. So this is just for the purpose which I'm using. I think you may try some more experimentation on top of it, right? So this is something which I'm doing here. So now 1900 number of rows, it has reduced it to 515. So I think here you might need to take with a pinch of salt, right? So of course you can use all of the tags which is surrounding in the universe, but the thing is we don't want to cover all of the website, right? If you try to all of the cover, then building the model and creating the training set would be very complex. So I'm just trying to keep the things very simple. Even if you could able to cover 95 or 98% of the website, we are happy with this. All right, similar analysis I'm doing on the tag names of the published date. So let's say I think let's go to the one of the blog which we have annotated, and let's go through inspect tag using the developer tools. And yeah, so here it's a time tag, right? So parental of tag of the time tag is span tag. So that's the, we are just doing the analysis on the parental tag of the published date tag. All right. So that contains, I think if you take the unique number of parental tags, that contains only div and span. All right. So now after doing it again, I'm restricting to the tags whose parental tag is div tag or it is span tag. Same explanation goes for the one which I explained for the published date tag. All right. I'm restricting the futures to only these columns, right? I'm not taking all of the columns which you are which we have in our data set. For example, URL is something which you don't need, right? Because you can do very minimal things with the URL alone. So, and also class text and right siblings and left siblings, this is something which I have learned. Definitely we can do some more analysis on top of it, but just for this analysis I have left these these three features. This is just for the sake. Okay, there is nothing like, of course you can feel free to do some kind of your own analysis on top of this. I was happy with the results what I got, so that of then I removed these what do you call it as features, right? So we just removed, then I think the data become very less, and I think also there are like so much of correlations between the features. There are like various things, right? Feel free to do your own analysis on top of this. All right, so now I'm just trying to consider only these columns, the columns I have mentioned here, right? So all right, and I'm doing the very standard cleaning process, right? I'm just ASCII values, removing the cleaning of the characters, like whatever it is. So once I'm cleaning it, what I'm doing is I'm storing in a variable called clean text length. Basically, you pass the text and clean it and measure how many characters in the text, right? I'm just storing that in a variable called, or in a column called clean underscore text underscore len, right? So just let's, now we have this value for each of the row in our data frame. So let's see how this the length histogram of the text length looks like. So if you look at the text length, it varies. I think it's morely the number, I think is less than 2000 characters, right? We have tags, very rarely it will go to 400 or above 400, but most of the text length is having less than 2000, or I think if you zoom in a bit, I think not zoom in literally here, I think when you do the operations of zooming in through the graphs, I think most of the values will be less than 1000 or so. But if you look into the text length of the tag, the text which contains the published date, it looks something like this. So observe here, most of the tags contains the text which between 10 to 25, or maybe like a bit more, right? So if you just analyze the graph of here and here, so I think just by using a typical rule base, I think you can get rid of most of the, I would say like not like all, most of the tags can be removed here, because like definitely a date cannot contain more than, let's say, 40 or 50 characters, right? I think yeah, there could be chance, let's say like 150 characters, right? So very rarely, I would say the date will never contain no text length will never exceed 150 character length, right? So this is what I'm trying to say here. I'll just zoom out a bit so that you will get a clear visualization. All right, so here you can see that 0 5, I think 10 15 20 25 just ending with 35, but as very here ending with 12,000. Also you can see that there are small hiccups here and there with after 4,000, and also I think somewhere near 9,000 and 9,500 we have some hiccups here. All right, now total number of one second, let me zoom in a bit. Okay, total number of data points is 320, and we have 13 such features. Not such features, I think we have 13 features. Okay, now just based on the text length, this is something you can do. I think we are just restricting to minimum text length and maximum text length. That means take each of the tags and get the clean it and measure the length out of it. If it lies between 8 and 70, then only keep it. Otherwise, just discard it. Okay. So this is just the analysis which I have done on the data which we're having, that is for the annotated data of 4 web URLs. All right. So now once we have I think what I'm doing is here, this is the condition which I'm making here, just keeping the text whose length lies between the 8 and 70. Once we have done those analysis, I think this is the ratio we will be ending up with. It is 81 are the tags which doesn't contain published date, 6 tags which contains the published date. Just look at the state we have got it. It was 1893, almost like 1900, right? From there we have reduced it to 81. Can say it's a very drastic reduction, right? So we have reduced in such a way that it doesn't harm any of the tags, right? You can close our eyes, you can remove the data points using these rows, right? And also we can, I think we can apply few more rules on top of this. Most of the date, if you observe, it will contain some or the other numerical groups, right? So when I say numerical groups, uh, I mean to say okay, let me close it. April 29 and 2021. Here 29 is a one numerical thing and 2021 is another numerical. Basically it contains two numerical group, right? So if a text doesn't contain any numerical group, then I think we may feel free to drop it down, right? Because if it doesn't contain any numerical group, I think there is no meaning in predicting whether it contains a date or not, right? So if it contains a numerical group, then it could be a published date. We cannot ensure that, but for that we need to do the ML modeling, which we're gonna discuss few minutes down the line. All right, so once we have keep the what you say this tags which contains the numerical groups, we fall down to 20 to 6. Just imagine we were started with 1900, oops, 1000, almost 900. Now here 1893 to 20. So I would say this is a very drastic reduce just because of the visualization analysis whatever we have done. Okay, and just remember, I know I'm repeating again and again, this is the analysis we have done just on the 4 URLs. Okay, all right, so far we have done the analysis and the visualization part, right, and also the cleaning part. Let's see how well we can encode, or you can typically how will you pre-process the data frame which you are having, that is overall 26 data points, right? I know building a model on top of it may look like a stupid because the training set is very very less, but I'm just here to give you a demo so that you can you can tag your own data set and start working on top of it, right? This is just a demo you can think of. And these are the typical standard traditional methodology I'm doing it. Of course you need not encode the ground truth data, but I'm just sake for the completion I'm doing it here. And I'm just using a try and test split and also dropping the test because there is no use of it once you got this. And I'm as encoding the HTML tag, that is the tag which is contains some kind of data and as well the parent of it. All right, once I have encoded it and I'm dropping it from the training set, and once I've got the encoded the training tag as well as the parental tag, I think what I'm doing is I'm just concatenating all three values, that is the HTML tag name and then the parental tag name encoded and the rest of the values which are in the training data set. So once we are done with all concatenation, I think we're gonna end up with 18 to 14. That means we have reduced to 18 rows and 18 data points, and each of the data point contains 14 features. All are in numerical in nature. All right, so similarly we are doing it for the text side here. I think you may observe it. I think text similarly, right? We just transform it. We have fitted the model earlier, now we are just doing the transformation. So now once we have the data, now let's look into the ML model perspective. So I'm just trying to assume few of the things, false negatives and false positive. This is our optimization, right? So these are the bunch of utility functions I'm trying so that you can build a model and quickly check the performance out of it. All right, so now here I'm not going to what you say this, I'm not going to do any kind of grid search or parameter search or Bayesian optimization to know the optimal hyperparameters, right? So just for assumption what I have made is number of estimators maybe 10, just a random one, maximum depth 12, and class is balanced, class weight balance, sorry, and random state is equal to 42. I'm just fit randomly, and obviously, right, I mean, like since the training set has it is like overfitted, right? So now I think what you can do is once you have the very well data set, maybe you can do for like 15 or 20 data points, sorry, web URLs, and annotate it and do the same procedure. You may do the grid search or the random search or whatever Bayesian optimization, and you will be able to get the good performance metrics here. So once I'm done with this, so I'm just saving the model out of it through the pickle dump file. I think I'm saving here is a job lib random forest model, and also I was talking about the encoder part of the tags, and that is the HTML tag, and that is the encoder part of the HTML parental tag. So I think utility dict function basically what are the other things which you have used, right? So finally I'm saving it in a job lib file. So now, so far we are done with the developing of the model. So now see how well we can make use of this model, right? So I think I'll zoom out. Okay, let me zoom in. All right. So now here, so I have, what I have done is I have, trained the model not on the 4 website, but I have also trained on the multiple I think somewhere around 35 to, I don't remember for how many URLs I did train the model, but I did train on somewhere around 35 to 40 approximately. Then similar analysis, whatever I shown you how done it, but I have saved the I think I have saved this underscore v1, right? When I was doing the saving, I think I had just removed the underscore v1 because that was the final version, right? So I have developed in terms of modules because that's how you will deploy it, right? So basically if you have like HTML encoder and also the ML part of it, and just reading the joblib files which I have saved in the previous step and extracting the publish date from the HTML, right? So I'll just give it a try like how it works. So basically what I'm doing here, I'm just trying to give the URL, just a random URL here, and this is the URL looks like, as and when you execute it, you will get the publish date out of it, right? Let's look into the URL once, how it looks like. Uh, Okay, so here, you can see here, I think this is one of the blog of Microsoft Tech Comment, whatever it is. So it says that publish date is 04/28/2021 5 a.m. and this is what we are getting here, right? So let's look into the, just for the sake of completion, just look at what exactly each of the classes is doing. So HTML encoder, what it takes is it takes the URL, it's a class basically, and it encodes it. So what it encodes is basically it will call the URL, it will get the HTML part, then it will create a soup object and cleaning up the soup object, then getting the HTML tag out of it and doing the future transformation, whatever you have done in the previous step, right? Doing the same step and get us the cleaned part of the data frame, right? So that you can build a ML model on top of it. So the ML model which you have already saved in the previous step. So we are just trying to use the same model and try to predict the publish date. And this is exactly what we are doing here. Extract publish date. This is a class which will take care of it. And I think there is a function called extract publish date which will help us to extract a publication date and give us the data frame, right? So I'm just as you may observe here, I'm just taking the first what do you say this first row. I'm just trying to place the example, right? So let's look into the how it looks like the data frame, right? Data frame would look something like this. This value whatever you're seeing and this value both are one and the same here. Just try to observe for a few minutes. And is date probability, I think what we are doing is we just descending order, right? And what we are doing try to do is we will say that this particular is a date by having a certain threshold fix. I think I have set a threshold of zero point 0.3, right? If you could able to anyway, I think if you could able to read it, so threshold is fair. Okay, sorry, 0.31. This is a threshold which I have set here. I had set here, and this is the result what I'm getting here, right? So all the results are false because the threshold is less than 0.31. So I think even if you try to give the other path, right? Other URL path, I mean, okay, and then let's see how it works. It is working, and it says 24th of November, right? And this is exactly 24th of November. So again, let's see how the the result file look like. This is looking like true because 0.75, it is it is having higher confidence than the previous one, right? So 0.31, I think threshold is something I had set it up because of depending on my observation. I think you may hear it depending on your observation. I think it depends, right? Now here I think we just extract the publication date. Now if you may extract the, let's say, title of the news or maybe the description of the news. For that threshold may vary. But this is how we can make use of the model. I will also make sure that this model and these files as well as these ipython notebooks are available in the github. So I will update the github link in the description section of this video. All right, I think we have almost reached at the end. So let's see uh, what are the extension we can do on top of this, right? So as I was saying here, you can use a threshold just to make sure that the one which you're returning is a date, right? This is one way of confirming it. But if you want to have a double confirm, just run the ner, that is named entity recognition, on the text side. So if it returns true, means you may double ensure that the one which you returning is a date, right? And also, right now I'm not using any kind of backend rendering tool like Selenium or PyPuppeteer, right? So I'm just using a request library, go request.get. Basically it sends a request to the sender, and whatever the response, I assume that that is an HTML in nature. So that's the reason I have taken only text blocks, right? You may go to the uh, news.google.com and get something like NDTV, or let's say Times Now, whatever. Basically it needs backend rendering. It makes the system bit slower, right, to in order to generate the training data and all. But of course this methodology can be used for those kind of websites as well, but you need to make sure that you are using Selenium or PyPuppeteer. Obviously the one of what you say, the third extension could be, which I have used, is using more training data, right? So I think this is a very beautiful tool which have we have created. That is I think just iterating to the same one. What is that? HTML. You can see. Oops. Okay, HTML tag annotator. So just try to use it. I'm sure you'll be getting benefit out of it. And leave in the comments like if there is any way we can improve this overall tool and make our life easier. All right. So thank you very much for watching this video.